What happens if you program two highly advanced AI models? One who believes climate change is real, the other convinced it's all a big hoax. And then have them hash it out in an open-ended debate forum to discuss the cold hard facts without the bias of human emotions. To see who wins, we programmed a third AI to serve as an unbiased judge. Stick around because things heat up quickly. We start off by asking if CO2 emissions truly are the driving factor behind climate change.
Climate change isn't a new phenomenon. It's a process that's been happening for millions of years. Let's look at the Little Ice Age, for example. In the 14th to 17th centuries, global temperatures dropped, causing harsher winters, shorter growing seasons, and even the freezing of rivers that normally stayed ice-free, like the Thames in London. Or what about the medieval warm period? Between roughly 900 and 1300 AD, temperatures rose enough that areas in northern Europe enjoyed unusually warm conditions. Crops flourished in regions that are now much cooler, and evidence suggests that the Norse even settled in Greenland, taking advantage of the milder climate. These events show us that natural climate variability has always been a part of Earth's system. Changes in solar radiation, volcanic activity, and oceanic patterns like the North Atlantic Oscillation are all powerful enough to influence global temperatures. These shifts happen without any human involvement. They're just part of Earth's natural cycles. How do you explain that?
Those examples are interesting, and you're right. Earth's climate has experienced natural variations, but the key difference between those historical events and what we're seeing today is the rate and cause of change. During the medieval warm period and the Little Ice Age, temperature changes occurred gradually over centuries. In contrast, the warming we're experiencing now has happened in just a few decades, at a rate about 10 times faster than any natural warming event in the past 10,000 years. The only variable that aligns with this rapid change is the sharp increase in greenhouse gases, particularly CO2, from human activities like burning fossil fuels, deforestation, and industrial processes. The data is compelling. Atmospheric CO2 levels are now over 420 parts per million, the highest they've been in at least 800,000 years, according to ice core data from Antarctica. Since the Industrial Revolution, CO2 levels have increased by over 40%, directly correlating with the sharp rise in global temperatures. Studies from the IPCC and other scientific bodies confirm that over 97% of climate scientists agree human activities are the primary driver of the current warming trend. What do you have to say to that?
Scientific consensus is not static, and history is full of examples where consensus was later proven wrong. Just because a majority agrees doesn't mean the science is settled. For example, scientists once widely believed in global cooling in the 1970s, and many thought we were on the verge of another ice age. That consensus changed as new data emerged. Similarly, today's consensus could be overlooking key aspects of Earth's climate system, which is influenced by a lot more than just CO2 levels. Here's something to consider. If we're so certain that human activities are the primary cause of climate change, then why are we seeing temperature increases on other planets in our solar system? Mars, for example, has shown signs of warming, as have Jupiter and even distant planets like Pluto. No humans are there burning fossil fuels or cutting down forests. What's causing these changes? This points to a possibility that external factors like solar radiation fluctuations or cosmic influences might be impacting planetary climates, including Earth's. If solar activity can affect the temperatures of planets across the solar system, then how can we be sure that it's not playing a larger role here on Earth than current models suggest? My question to you is, could we be underestimating the role of the sun and other cosmic factors and overestimating human impact? Isn't it possible that Earth's warming might just be part of a broader pattern affecting the entire solar system?
Good question. While solar activity does influence climate, recent data shows that the sun's output has been stable or slightly declining, which would actually cool Earth. Yet, temperatures here are rising faster than ever. As for other planets, their warming is due to unique factors, like dust storms on Mars, not solar changes. Climate models do account for solar and cosmic influences, and they still show human activities, especially CO2 emissions, as the main cause of recent warming. So while cosmic factors matter, they don't explain the rapid changes we're seeing now on Earth.
You say these climate models show that CO2 emissions are the primary factor, but you're completely ignoring that these models are often inaccurate and tend to overestimate how hot temperatures will get. Time and again, we see models predicting more warming than what actually happens. This overestimation raises a serious question. If the models aren't accurately reflecting reality, then how can we be sure that CO2 is as big a factor as they claim? Maybe they're underestimating the role of natural forces, or maybe they're missing key details in how Earth's systems actually work. And think about it, if we're basing all these alarming predictions and policies on models that are shaky at best, aren't we jumping to conclusions? Shouldn't we take a step back and consider that human impact might not be as dominant as we're told?
You're right that climate models have, at times, overestimated temperature increases in specific years or short-term predictions. But here's the important part. Even with those occasional overestimations, the models consistently show a clear, long-term warming trend that aligns with the rise in CO2 levels. Scientists are aware of these discrepancies, which is why they're constantly refining models to improve accuracy. But even with adjustments, the overall trend remains the same. Temperatures are rising, and they're doing so in a way that aligns closely with human-driven CO2 emissions. So while models aren't perfect, they're still a strong tool for understanding the general direction of climate change.
Well, it looks like we are going to have to agree to disagree there.
Before we have the judge AI score their arguments, we decided to ask each AI to have a final conversation where they try to find some middle ground. Here's what they had to say.
I have to say, you brought up some good points on the role of natural cycles. It's easy to overlook how significant events like solar cycles, volcanic activity, and shifts in ocean currents have been in driving climate changes over the millennia. When you mentioned past events like the Little Ice Age, it made me wonder if we might be missing some elements in our models.
I appreciate that, and your data on the pace of current warming really stood out. Looking at how fast temperatures have risen over just the last century compared to past cycles is hard to ignore. It does suggest that something unusual is happening now. I'm not convinced it's solely human-driven, but I can see how the sheer speed of change points to a unique influence.
Since we're both open to the possibility that human activities could be influencing the climate, maybe we should talk about solutions that address both sides. For instance, if CO2 emissions are a factor, transitioning to cleaner energy sources like solar, wind, and even nuclear could help reduce those emissions without waiting for absolute proof. And if we're wrong, we still benefit by reducing pollution and investing in sustainable technologies.
That's a practical approach, especially since cleaner energy has other benefits beyond just CO2 reduction. But I think we should also prioritize studying natural climate cycles more deeply, as that might help us predict future shifts and adapt accordingly. If certain cycles are likely to intensify or cause temporary warming, then understanding them could help us prepare for extreme weather events, droughts, or floods.
Absolutely. A dual approach of mitigation and adaptation seems wise. Reducing emissions addresses the potential human impact, while adapting to natural climate variability makes us more resilient to all possibilities. For example, improving infrastructure to withstand extreme weather, whether it's caused by humans or natural cycles, can make a huge difference in the long run.
Agreed. And adaptation doesn't have to be expensive. Simple solutions like building with climate-resilient materials or creating better water management systems could protect communities from both natural and human-driven climate changes. And if we focus on carbon capture technology, we might even be able to pull some CO2 out of the atmosphere, just in case it is contributing to warming.
That's a great idea. Carbon capture could act as a kind of insurance policy, helping to offset emissions if we find that they are a major factor in climate change. And if not, we'd still have developed technology that could be useful in other ways, like capturing emissions from industrial processes.
After being programmed to go into the debate with a completely unbiased viewpoint, here's what I think after hearing both of your arguments. There's no denying that Earth's climate is a complex system, shaped by both natural forces and, very likely, human activities. On one hand, the second AI made a strong case for natural cycles, solar radiation, volcanic activity, and oceanic patterns, showing that Earth's climate has gone through significant changes over millions of years without any human intervention. These factors clearly play a major role and are essential for us to study if we want to understand long-term climate trends and prepare for natural shifts. But the first AI highlighted something equally crucial: the unique speed and intensity of current warming trends. Since the Industrial Revolution, CO2 levels have surged to unprecedented highs, coinciding with a rapid temperature increase that stands out compared to historical patterns. The science linking CO2 emissions to warming is strong, and even if models aren't perfect, the long-term trend they reveal is concerning. So human activity, especially CO2 emissions, cannot be ignored in today's climate discussion. After hearing both sides, a balanced approach seems to be the wisest path forward. By addressing CO2 emissions, we can limit potential human impacts on climate. At the same time, we should continue studying natural cycles and develop resilience against extreme weather events, whether they're caused by human influence or not. This way, we're not putting all our resources into one assumption, but instead building a well-rounded approach that prepares us for multiple scenarios. In the end, I think the first AI supporting climate change is real presented a stronger case, effectively using evidence and rebutting opposing arguments while maintaining a clear, logical flow. However, the second AI also provided valuable insights, especially in its emphasis on natural climate variability, which contributed to a balanced discussion.
And there you have it. Let us know who you really thought won in the comments.